Hello and welcome to Mike Academy. So in this video, we are going to be looking at the Newton-Raphson's method of numerical methods, and we are going to be focusing on square roots. Now let's say x is equal to the square root of n, okay, and we are asked to approximate this the root of this equation using the Newton-Raphson's method. How do we go about this? Now, in order to do this, the first thing to do is to eliminate what? This square root, right? Now, to do that, we simply take the square of both sides. So we are simply going to have x squared is equal to what? N. Now, if this happens, you can simply send n over to this side just to make this equation of the form f of x equal to 0. So if we send n over here, this simply implies that x squared minus n is equal to 0. So we've gotten our function. Therefore, we can simply have that f of x is actually what? X squared minus n. Now, you remember your formula. The Newton-Raphson's method simply states xn plus 1 equals xn minus f of xn all over f prime of xn. So looking at this equation we've obtained now, we can simply say we have found our f of xn to be equal to x squared minus n. Simply this becomes now the given function. So we need to now find f prime of xn. So which means we need to differentiate this variable. And if we do that, we are going to have 2x. And since n is a number, derivative of n simply becomes 0. Now we have this. Let's plug that into the Newton-Raphson's formula. If we do this, we are going to have xn plus 1 to be equal to xn, okay, minus our f of xn simply gave us x squared minus n. So we simply have x squared minus n all over f prime of xn. That gives us 2x. Now, you can simply say this is f of xn. Let us call x squared to be what? X squared n. And same thing here. 2x here simply becomes 2xn. So we'll effect those changes here as well. So this is x squared n. So f prime of xn becomes 2xn. And you have this. Now, you can simply cross multiply. If you do this, xn plus 1 simply becomes 2xn multiplies xn. That gives us 2xn squared minus times xn squared there becomes negative xn squared minus times this minus here becomes positive. So I have plus n all over 2xn, and you have this. So you can evaluate this to be equal to 2xn squared minus xn squared. That simply gives us xn squared plus n all over 2xn. So you can rearrange that equation and you're going to obtain xn plus 1 to be equal to, this is simply xn squared all over 2xn plus n all over 2xn. So this can also give us, of course, xn squared goes into xn. I will simply have xn all over 2 plus n all over 2xn. Okay, now you observe that between these two, 1 over 2 is common between them. So this simply implies that for a given square root, your next approximative value using the Newton-Raphson's method is simply going to be xn plus 1 equals 1 all over 2 is common into, I will simply have xn plus n all over xn. So whenever you're given to approximate the root of an equation, which is of a variable which is a square root, of course, you're going to simply make use of this formula, and it is very easy to use. And you can find the root of that given equation in a very simple step using this equation. Now, we're going to use an example to explain this concept. So I'll use a very simple example. Let's say we're asked to find the root of x equals square root of 10. Now, you can actually punch the square root of 10 in your calculator, but let's use Newton-Raphson's method, specifically this formula for what? The square root of a function, to actually what? Carry out this approximation. So remember, the first thing to do, you take the square of both sides. If you do that, you're going to have x squared to be equal to what? 10. Now, simply send 10 over here so that the equation can be of the form f of x equal to 0. If you do that, you're going to have x squared minus 10 to be equal to 0. So this simply implies that my function f of xn is now equal to what? X squared minus 10. And you have this. Now, we need to find our initial guess. I've always said this, that if you're not given a value of the initial guess in the given question, then you simply employ the normal formula to obtain our initial guess. And the formula is simply x naught is equal to a plus b all over 2, where a is a value that causes the function to be positive and b is a value that causes the function to be what? Negative. And these two values are obtained such that when you plug them into the function, it causes the function to change from positive directly into negative, or from negative directly into positive, and so on. Okay, so let's choose a scale of 2. So we can choose 0, 2, 4, and above. Okay, so if x is 0, then you plug in 0 into this equation, you find f of 0. This is going to be equal to 0 squared is 0. So I have 0 squared minus 10, which will give me negative 10. And this value is negative. Let's consider when x is 2. I will find f of 2. This is going to be equal to 2 squared. That is 2 squared minus 10. And 2 squared is 4. 4 minus 10. This simply gives me negative 6. Again, we also have a negative value. Now we choose when x is 4. We simply have f of 4 to be equal to 4 squared, okay, minus 10. So f of 4 is going to be equal to 4 squared is 16. 16 minus 10 simply gives us plus 6. Now this value is positive. So you see now that the equation or the function changes directly from negative into positive when x is 2 and when x is 4. So this simply means that my a is the one that causes the function to be positive, which in this case is 4, and b is simply the one that causes the function to be negative, which in this case is 2. So directly from negative to positive is when x is 2 and when x is 4. Therefore, my initial guess, x naught, is now equal to, we said a plus b divided by 2, and a is 4 plus 2, so you have 4 plus 2 divided by 2. 4 plus 2 is 6 divided by 2. This implies that my initial guess is equal to what? 3. So my x naught simply gives me 3. Now, I want to use this equation to actually solve for this question, right? Now, the next thing to do is simply plug them into this formula. So this is x naught, which means when n is equal to 0. So if I plug n here as 0, xn plus 1 becomes x0 plus 1, which is actually x1. So that gives me my first iteration. x1 is going to be equal to 1 all over 2 into xn, and xn is x naught plus n all over x naught. So this is equal to 1 all over 2 into xn, which is x naught, is 3. Our x naught here is 3. So I have 3 plus n is the number itself, and the number is 10. Okay, so we have 10 divided by xn once again is 3. So x1 first root is going to be equal to 1 all over 2 into, so let's evaluate 10 divided by 3 plus 3. So let's take correct to 4 decimal place. That gives us 6.3333. Now let's multiply this value by 0.5. So that simply gives us 3.1667 approximately, or correct to 4 decimal place. So we'll have our first root x1 to be equal to 3.1667. Now, to find the next root, which is x2, you simply plug in the value back into the function or the formula. Now, you plug in this new iteration into the formula to find the current approximation, which is going to be x2. So in this equation now, instead of xn, or instead of x1 here, this becomes x2, and this becomes x. This becomes x1, and this becomes x2. So we're going to have x2 to be equal to, still the formula remains the same, 1 all over 2 into x1 now, which is the value we found, plus n over x1. So it's a very simple procedure. So we can now find our second root, x2 equals 1 all over 2 into x1, which is 3.1667, plus 10 divides x1 again, 3.1667, and you have this. So we can find the second root. This is going to be 1 all over 2 into, let's evaluate everything inside the brackets. So 10 divides 3.1667 plus 3.1667. This gives us 6.3246 approximately. So if you multiply by 0.5, you're simply going to find the value of the second root, x2. So multiply this by 1 over 2. And that simply gives us 3.1623 approximately. 3.1623. So you see that correct to two decimal place, this root has actually converged. In x1 we have 3.16. In x2 now we have 3.16. So you can choose to stop your iteration here depending on what the question is asking you. But let's try in this video to see if we are going to find it up to 4 decimal places correct. Let's try and see. So the third root becomes x3. So we fall back to the formula and plug in now x2. So we simply have 1 over 2 into x2 plus n all over x2. So this is going to be equal to 1 all over 2 into x2, which is the value we just obtained now, is 3.1623 plus 10 all over 3.1623. So let's evaluate everything in the bracket and see what we are going to have. So 10 divides 3.1623 plus 3.1623. That simply gives us 6.3246. So multiply this by 0.5. 6.3246 times 0.5. That simply gives us 3 points. We have 3.1623. And if you compare this to the previous root, 3.1623, the root of the equation has actually converged correct to 4 decimal place. So you can go ahead to find the square root of 10 naturally, and you're going to find out that the value is still approximately 3.1623. So that is how to employ the Newton-Raphson method to solve numerical problems involving square root of a given function. In the next video, we're going to be looking at the one involving a cube root. I'm sure you want to be a part of that video, so do well to hit the subscribe button and turn on your notification bell so you don't miss out on that video when it drops. I will see you in the next video. Cheers.